In the introduction video, we discussed how Chapter 1 is all about teaching you to communicate mathematically. So we want to be able to translate between English statements and put them into their formal mathematical counterparts. So let's start off by discussing what a statement is. A statement could also be referred to as a proposition. A statement is a declarative sentence that is either true or false, but not both. For example, the sentence 7 is odd. That sentence is always true based on our definition of odd numbers, so we can call that sentence a statement. The sentence 1 plus 1 equals 4. That statement is always false, or that sentence is always false, so we can also call it a statement. And statements don't necessarily have to be about mathematics. For example, the sentence, if you are under 18, then you cannot vote. Well, being under 18 is either a condition for voting or it's not. Rather, being over 18 is either a condition for voting or it's not. It can't be both. So this sentence is also a statement. Similarly, if we look at the sentence, our professor was born in Alaska, well, either your professor was born in Alaska or they were not. For your professor, me, I was born in North Carolina, so that sentence is false. But the point is, a professor cannot be born in two places. They're either born in Alaska or they are not, so this sentence is also a statement. An example of a non-statement could be something like the sentence, x is even, because it depends on what x is. X is a variable, so if x is 2, 2 is even, and the sentence is true. But if x is 3, say, then 3 is not even, and that sentence would be false. So any sentence that involves a variable like this is not a statement because it's true for some values of x and false for other values of x. What about the sentence, this sentence is false? Well, if we think of this statement as being true, then that would mean this sentence is false. But if we think of this statement as being false, but that would imply the sentence is true, and that's the kind of loophole we don't want to get stuck in math. So whenever a sentence is self-referential meaning it refers to itself, then that sentence is not a statement. So in order to formalize logic, we need a system for translating statements into symbols. And we're often dealing with more complicated statements that consist of several simple statements joined together by words such as and, or, if, then, etc. And we call these connecting words the 5 logical connectives. So our formal system for logic, we want to be able to translate between a statement in English and its formal counterpart. And we do this by assigning letters to simple statements and then building our expressions with those logical connectives. So here are the 5 logical connectives. You definitely want to be able to recognize these symbols and translate them into their English name. So our first symbol is this wedge symbol. It's like an upside down V. In English, we read that symbol as and. We also have this symbol V. We read that in English as the word or. The negation symbol, we read that in English as the word not. A right arrow, we can read that one of 2 ways. We can say the right arrow reads as the word implies, or we can say something like if the left-hand side, then the right-hand side. So it can also represent an if-then statement. And our final symbol is the left arrow combined with the right arrow. So it's an arrow that goes in both directions, and we read that in English as the phrase if and only if. And what that means is that we can read if the left-hand side, then the right-hand side. And we can also say if the right-hand side, then the left-hand side. So an if and only if statement can be read in both directions. So an example, if we let the letter P represent the statement you are wearing shoes, and the letter Q represent the statement you can't cut your toenails, what does P right arrow Q mean in English? Well, we could say this means P implies Q, or we could read it as if P, then Q. And we also want to substitute what P and Q represent in English. So the final answer would be something like if P, so if you are wearing shoes, then Q. Then you can't cut your toenails. If we look at the same statements, what does P wedge Q mean in English? So recall this wedge symbol represents the English word and, so we're trying to say P and Q. And so if we substitute what P and Q represent in English, we would get something like the sentence, you are wearing shoes and you can't cut your toenails. So the idea here is that we don't want to spend lots of time writing these really long, complicated sentences. We want to be able to use some kind of shorthand notation, and that shorthand notation is this formal mathematical logic symbol, because it will save us lots of time and energy rather than writing out these long English statements. So why don't you try a few? Look at the same statements. P, you are wearing shoes. Q, you can't cut your toenails. And see if you can translate the following into English. So try P, V, Q. Try to determine what it means when we negate Q in English. And also take a look at P, left and right arrow, Q. See if you can translate each of these three sentences into English, and let me know at the beginning of next class if you have any questions.